Now I want to take a few minutes to talk about the graphical representation of elasticity, how these different types of elasticity relate to different points along the demand curve. In this class, I'm going to be asking you to calculate the point elasticity of demand, and you'll see how that works in the calculations in a future video. But it is important to recognize that in some classes, professors will ask you to calculate elasticity using a midpoint formula. In other words, the midpoint between two different points along the demand curve. I will not be using the midpoint formula. So if you see that in a book or if you used that in the past, just know that that's not exactly what we're doing. The reason that I ask you to calculate the point elasticity of demand is that it's a bit simpler. Rather than first finding the midpoint between the 2 points and then calculating the elasticity, I ask you to just calculate the elasticity at a single point along the demand curve. So I just want you to be aware of that difference between what we're doing in this class and what you may see in the book or in other classes. If we look at a demand curve, any demand curve, we will see that it has elastic points, inelastic points, and a unit elastic point. Now I want to talk a little bit about how demand relates to our total revenue function. So here I have a graph of a demand curve with some elasticities already labeled, and I also have a total revenue function. We'll treat this as a generic demand curve. So say that this demand curve has a y-intercept of A and an x-intercept of B. What do those intercepts mean? At the price of A, I know people will buy 0 of this product, right? So this is the price, which we sometimes refer to as a choke price, at which the quantity demanded goes to 0. Nobody's willing to pay more than A for this product. So what is the total revenue at this point? If the price is really high, but the quantity purchased is 0, then of course the total revenue from sales will be 0. If we look at the other end of the demand curve, here, people purchase a quantity of B, but the price is 0. So this is the quantity that people will purchase if the price is equal to 0. And of course, that's also going to give us 0 total revenue since you're just giving this product away for free. And you'll see that in between these 2 points, our total revenue function at first increases and then decreases, reaching its maximum here at the unit elastic point. And when we have a straight line linear demand curve, as we will always have in this class, the midpoint of the demand curve the unit elastic point occurs at the midpoint of the demand curve. That means that the unit elastic point here occurs at a quantity of B over 2 and a price of A over 2. So to find the midpoint of demand, you just divide the intercepts by 2, and you know that that will be where the unit elastic point is. Every point above that point will be elastic, and every point below that point will be inelastic. And you can see that if we have an increase in price along the elastic portion of the demand curve, we're moving away from the maximum total revenue point. I know that total revenue will decrease. So on the elastic portion of the demand curve, because I'm moving away from this maximum total revenue point as the price increases, total revenue goes down. Now, increases in price along the inelastic portion of the demand curve mean that I'm moving towards the maximum total revenue point. My total revenue is increasing. So here, price and total revenue will move in the same direction. All right, so I hope that these graphs help you understand a bit more clearly the relationship between the point elasticity and total revenue. And in the next video, we'll practice, finally, calculating the price elasticity of demand.